All right, so we've already learned how to solve quadratic equations or degree 2 polynomial functions by factoring. Well, we finished up our lessons on how to solve by factoring, and today we're going to start some lessons that focus on solving by completing the square. So this is a new method, but what we're solving for hasn't changed. So when I say to solve a quadratic equation or a degree 2 polynomial function, what do I really mean? I mean find the x-intercepts. So you're solving to find the x-intercepts. And what else can we call x-intercepts? They're also known as zeros. So what we're really trying to find are the zeros. And on your notes here, I've just added a little graph to remind you, and keep in your mind that when we graph a parabola, it's going to hit the x-axis in 2 spots. Those are the zeros. Those are the x-intercepts. That's what we're doing. That's what we're solving for. Okay, so I've got all of the steps for solving by completing the square written out for you. We're going to follow these steps one by one as we solve the first example. So the first example is y equals x squared plus 14x minus 38. Going back up to the steps, step one is to make sure that the equation is equal to 0. So we want to make sure that we plug in 0 for y. So we're going to plug in 0 for y. 0 equals x squared plus 14x minus 38. To be able to solve a quadratic equation, it has to be equal to 0. So step one is done. Just kidding. Step one is done. Step two, isolate the ax squared and bx terms on one side of the equal sign. Ooh, that should say sign, not side. Silly me. One side of the equal sign. So 0 equals x squared plus 14x minus 38. We want the x squared and the 14x term on one side, and we actually want to move the 38 to the other side. So I'm going to have 38 is equal to x squared plus 14x. So we've isolated the x squared term and the x term on one side and moved the 38 to the other side. And that's just something that we do for solving with this method. All right, now to complete the square, we have to do this little trick. We're going to take the value of b and we're going to divide it by 2 and square it. So what we're going to use to complete the square, we're going to use b divided by 2 squared. So notice that our b comes from our bx term. Remember, standard form is y equals ax squared plus bx plus c. So b is whatever's attached to the x term. So our b is 14. So we're going to take 14, we're going to divide it by 2, and we're going to square it. So we get 14 divided by 2 is 7. 7 squared is 49. So we did step 3. We took b divided by 2 and squared it. Step 4. Add what you found in step 3 to both sides of the equation. So we're going to take this 49 and we're going to add it to both sides of our original equation. And I'm actually going to write that in purple. So we're going to take 49 and we're going to add it to the 38. And we're going to add it to the x squared plus 14x. So we're going to add it to both sides. So the reason we added it to both sides is because what you do to one side of an equation, you have to do to the other. So if I added 49 to the left side, I also have to add it to the right side. Okay, so we did that. Now rewrite the standard form side as a perfect square. So when I say that, what I really mean is factor that side. So we're going to factor the x squared plus 14x plus 49. So on this side, 49 plus 38 is 87. And then x squared plus 14x plus 49. So we can actually factor this side. So this side becomes x times x is x squared, and then 7 times 7 is 49, and 7 plus 7 is 14. So this side factors to x plus 7 times x plus 7. Well, how can I rewrite something times itself? Can't I rewrite this as x plus 7 squared? So now we've written this side of the equation as a perfect square. X plus 7 squared, something times itself. So step 5 is done. Step 6, now solve the equation algebraically. So now we have 87 equals x plus 7 squared. We're going to solve this equation. And I'm actually going to do that over here so I can kind of keep my work separated, the factoring from the solving. And I'm going to switch colors. So 87 is equal to x plus 7 squared. All I did was rewrite this equation over here. How do I cancel squaring something? So the way we cancel a square is to square root. So we're actually going to square root both sides here. So 87 isn't a perfect square, so we're just going to leave the square root of 87 as the square root of 87. But something that you need to watch out for is when you square root both sides of an equation, square rooting gives you two answers. And to show those two answers, we're going to have a plus and a minus out in front of our square root. So when I square root both sides, I really get plus or minus the square root of 87 equals, then the square root of the square cancels, and you're left with x plus 7. So you're left with what's under the radical, x plus 7. So now I need to get this x by itself, so I'm going to subtract the 7 to both sides, and I'm going to be left with x equals. So if I have the square root of 87, am I allowed to combine that with 7? So 7 does not have a radical attached to it. We can't just subtract it from the square root of 87. So we're actually just going to write it as negative 7 out in front plus or minus the square root of 87. So what this gives us is our two answers. Just like when we solved by factoring and we ended up with two answers, we still have two answers. We have negative 7 plus the square root of 87, and we have negative 7 minus the square root of 87. So I have x is equal to negative 7 plus the square root of 87, and I also have x is equal to negative 7 minus the square root of 87. The square root of 87 can't be reduced, so we're going to leave our answer like this, and when you tell me what x is equal to, you can either write it as x equals negative 7 plus or minus root 87, or you can write it as x equals negative 7 plus root 87, comma, negative 7 minus root 87. So either of those ways will work, just depending on your preference. So let's do that one more time. I know that was crazy. Let's do it again. So example 2, we're going to follow those same steps as earlier, but I'm not going to go over them one by one. You can write them down and use them one by one, up to you. So let's try this out. So step 1, I want to make my equation equal to 0. So 0 equals x squared plus 14x minus 51. Then I know that I want to isolate the x squared and the x term. So I'm going to move 51 to the other side. 0 plus 51 is 51 equals x squared plus 14x. So now x squared and 14x are isolated. So now we need to find the number that we want to add to both sides of this equation. So to do that, we're going to take b, we're going to divide it by 2, and we're going to square it. So our b is 14. So we're going to take 14 divided by 2 and square it. 14 divided by 2 is 7. 7 squared is 49. So now we're going to take this 49, we're going to add it to both sides of the equation. So we're going to have 49 plus 51 is equal to x squared plus 14x plus 49. was just making sure this wasn't the exact same equation we just did. All right, so what's 49 plus 51? So this side becomes 100 equals x squared plus 14x plus 49. And now we need to factor the right side. So we actually already factored x squared plus 14x plus 49 in the previous problem, except this time it's equal to 100. So x plus 7 times x plus 7. I can rewrite that as a perfect square, x plus 7 squared. So now we're ready to solve. So 100 is equal to x plus 7 squared. How do I cancel a square? Well, I square root both sides. How many answers do I get when I square root both sides? 2. How do I show that? Plus or minus. Now this time, what's the square root of 100? 10. So we get plus or minus 10 is equal to, and then the square root cancels the square, so we're left with x plus 7. Now you're going to subtract 7 to both sides, so negative 7 plus or minus 10 is equal to x. Now because the 10 is not under a radical, this time we can actually simplify our two answers. Right here we have x equals negative 7 plus 10, and x equals negative 7 minus 10. So x equals 3, and x equals negative 17. So then our answers are x equals 3 and negative 17. And let's do one more example together. So solve this degree 2 polynomial by completing the square, just like we did before. So this equation is kind of nicer because it's already equal to 0 for us. So because of that, we're ready to isolate the x squared and 6x term. So I'm going to subtract 8 to both sides. 0 minus 8 is negative 8 equals x squared plus 6x. Now to figure out what to add to both sides, we have to do the b divided by 2 squared. So why don't you do that real quick? So what you should have found, since b is 6, 6 divided by 2 squared is 3 squared, which is 9. So we are going to add 9 to both sides. So 9 plus negative 8, oops, just kidding, equals, and then x squared plus 6x, and then you're going to add 9 to that side. What you do to one side, you have to do to the other. So what's 9 plus a negative 8? This simplifies to 1. Equals, and then what does x squared plus 6x plus 49 factor to? So you want to factor this side so it ends up being a perfect square. So x times x is x squared, 3 times 3 is 9, and then plus 3 will get us that positive 6 in the middle. I can rewrite this as x plus 3 squared. And now we're ready to solve, and I'm going to do that step over here. So we have 1 equals x plus 3 squared. So to solve this, we need to cancel this square. So we're going to square root both sides. Hey, what's the square root of 1? 1. But when I take the square root, how many answers do I really get? 2. Plus or minus 1 is equal to the square root and the square cancel, so I'm left with x plus 3. To finish this, I'm going to get x is equal to, we need to subtract 3 to both sides, so negative 3 plus or minus 1. So x is equal to negative 3 plus 1, x is equal to negative 3 minus 1. X is equal to negative 2, x is equal to negative 4. So my final answers are x equals negative 2 and negative 4. And that is your introduction to solving by completing the square.